Okay, I'm going to talk to you guys about another STEAM connection of art and math. The last STEAM connection that we made was in a video that I called Clay Shrinkage. We talked about how when artists make anything in clay, you need to know, first of all, how big you want it to be when it's done. And then you need to figure out how big you have to make it so that it shrinks to the proper size, okay? I'm not going to talk about that right now because we've already talked about it, and I will refer back to it later in the video, okay? All right, so once again, today's STEAM connection is art to math in clay. Before I start with the math that I need you to understand, I want to tell you about two vocabulary words that will be important for you to know. The first word is diameter, and some of you might already know what this word means. It is a straight line that starts on one side of a circle, passes through the center, and ends on the other side. So, if I was going to draw a diameter, I would be starting on one side, and by the way, in real life, you might want to use a ruler, but you get the idea. That's the diameter of the circle. Okay, diameter. The next vocabulary word that you'll need to know is proportion. Proportion is a comparison of the size, quantity, or weight of objects. So here's my example. Two guys. One of them is 6 feet tall, one of them is 3 feet tall. A proportion is a comparison, remember, okay? And when we set up a proportion in math so that we can compare the items, we always want to put the part over the whole, okay? That means the part is always going to be the smaller thing, and the whole is always going to be the bigger thing. So, part over whole in this case would be 3 feet over 6 feet, okay? That's how you set up a proportion. All right, that's the vocabulary. Next, let's get to our math problem that we need to know in order to figure out how big we're going to build our clay cups when they're wet so that they shrink to the proper size after they're fired. Okay. Everybody is going to have a sketch plan. You are going to sketch the mug that you're going to build, and in that sketch plan you're going to include how tall you want it to be and how wide you want the inside diameter of the cup to be, which is actually a circle, remember, okay? Now, here's my sketch plan, and hopefully you can see that. Here's my mug. I'm saying here that I want the height to be 4.5 inches tall, and I want the inside diameter to be 3.5 inches. Can you see that now? I have to put this back because it's a magnet. Okay. The problem is I want to build a cup that will be 4.5 inches tall, or 4.5, and have a 3.5 inch inside diameter after firing. So that's how big I want it to be when it's done, when it's all done shrinking. Now, right here it says the unfired cup, or the wet cup, will shrink to 88.4% of its original size when fired. Now, the original size when fired is considered the whole cup, or the 100% cup, okay? And I'm going to write that, actually I'm going to write it in black, right here, right next to the word original, okay? See that? Now right here, this sentence right here, the unfired cup will shrink 88.4% of its original size. I'm sorry, it's going to shrink to 88.4% of its original 100% size when fired. This is given information, okay? We know what the problem is. We need to find out how tall and how wide the cup needs to be when it's wet. Now, right here, here's where the word problem is asking you what it needs. How tall must the unfired cup be, and how wide must its inside diameter be in order for the cup to shrink to the dimensions in the sketch? Okay, that's what I just said. Your solution right here is to use proportions. You're going to compare the sizes of the cups. You're going to compare the size of the whole cup or the wet cup to the size of the wet cup. The dry cup. All right? Compare the whole cup, which is the wet cup, to the fired cup, which is the dry cup and the smaller cup. Okay. Here we go. Right? Wet is 100%. Here it is, the whole cup. Fired is 88.4%, which is the partial cup. All right? In the last video that you saw, we figured out that the fired cup is 88.4% of its original size because we took the whole cup, we said it was 100%. Remember that little diagram where I said it's going into the kiln and it shrinks 11.6%? And when it's done, it's 88.4% because 100% minus 11.6% is 88.4%. Once again, this is your given information, okay? So, we've gone through the word problem. We've talked about the given information. Now I want to tell you how to set up the problem to figure out how big you need to build that cup, okay? Okay. This word problem has two parts. The first part is we need to figure out how tall to build the wet cup, okay? And that's what we're going to do right here. Part one, how tall do we need to build the wet cup? Well, we're going to compare the wet cup to the fired cup, just like we compared the two guys, all right? We know that the wet cup is considered the whole cup, which is 100%, okay? We don't know how tall to build it, so we've labeled it X. We know that the fired cup is considered the part, which is 88.4%. And we do know that we want it to be 4.5 inches. All right? Now, here's how you set up the math problem. Remember, part over whole. So 4.5 over X. Okay? That's how tall the part cup is going to be is here, and how tall the whole cup is X. We don't know. Now, we do know that the part in percentage is 88.4%, and the whole in percentages is 100%. So, let's use this information to figure out what X is, or how tall to build the wet cup. So, we're going to cross multiply. So let's see, first we're going to say X times 88.4%. And 4.5 times 100%. Gives us 88.4X equals 450. We have to isolate the X. So we need to divide by 88.4 on both sides. And here the 88.4 sort of cancels itself out. Here, 88.4 divided into 450 is 5.09. I did that on a calculator. Or, if you round this number up, the 9 turns the 0 to really a 1, right? So that gets you 5.1. And I would prefer that you round X to the nearest inch, so 5.1 would really give you 5 inches. Okay? X equals 5. X equals 5. Your wet cup has to be 5 inches tall. Part 2. How wide does the inside diameter of your wet cup have to be? Once again, we know that the wet cup is considered 100%, okay? We don't know what x is, all right? That's what we're trying to find out. But x has to go on the bottom because it represents the whole. 3.5 inches goes above the x because it's considered the part. We do know that in percentage, the part equals 88.4% and the whole equals 100%. Now we have to cross multiply. Okay, 88.4 times x equals 3.5 times 100. That gives us 88.4x equals 350. We have to isolate the x, so we have to divide by 88.4 on both sides. That cancels out, leaving us with x equals 3.96. I did that on the calculator, which rounds up to 4.0. X equals 4. Your wet cup has to be 4 inches in diameter in order for it to shrink to the proper size. When you set up your own math problem, you're going to look at your sketch, okay? And you're going to plug in your own measurements that you want your cup to end up to be, where I plugged in my measurements in this example, okay? Any problems? See me in class. Bye. You can do it.